Alright, UFC Unified Facility Control Operational Maintenance of Petroleum Facility 346003, January 21st January 2003. Chapter 4, Hydrant Fueling System Type 1 Panero. 4.1 General Information provided the development of hydrant fueling system. The aircraft was refueled from drums of aviation fuel that would be hauled with the aircraft. Later, fuel was transferred to the storage tanks into the trucks that could be pumped into the fuel into the aircraft. The method is adequate for the over-the-wing filling in a relatively small aircraft. They may provide the efficiency time consuming for a large aircraft being built. 4.2 Original Panero. There was the first hydrant system in the Air Force that was built throughout the 1940s and 1950s. The system was based on a concept bringing the aircraft to the fuel. The fuel was pumped through a single refueling outlet to the edge of the aircraft parking ramp, and the aircraft had to be moved to the fueling outlet, refueled, and moved back to the parking location. This reduced the need for the truck refueling. The original Panero system had two automatically controlled valves. The filter meter pit on one of the refueling lines and separate valve with the defueling line. Since hydration systems are constantly improved, upgraded, there are few original Panero systems left. Major modifications of original Panero created with the modified Panero system. The modified Panero system is still some of the military installations today use automatic control valve with 302 AF refuel defuel control valve in the filter meter pit in both refuel and defuel operations. This chapter includes the description of modified Panero's operation, major components, and pressure setting. Figure 4.1. Alright, basically, this shows the modified Panero Type 1 hydration system. Like you have a manual valve, a filter separator, if you want to do a Panero means the line goes following this direction into the underground tank and then back through this to a hydrant LCP. You can barely read the thing, but like if you lay the track this way, around the defueling and returning line, that's Panero. Pritchard would go straight over the manual valve lane between manual valves, like this way. Alright, 4.3 Modified Panero Systems Operation. When the fuel is required for the hydrant oil outlet, the operator places a magnet of refueling magnet control assembly with the KISS switch that energizes the pre-selected system refuel pump solenoid on the 302 AF valve. This fuel is pumped through the system, flows through the several components with the use of figures to follow the flow, and fuels is stored in the underground operating storage tanks. A pump house sits directly over the underground tanks. The pump house contains pumps, field separator, piping valves, and other components. The pump draws the fuel to the tank and forces it through the filter separator at the rate of 1135 to 2271 liters per limited to 600 gallon per minute. The fuel flows into the main refueling manifold to connect to the lines called laterals. Along the laterals, the lines pass through the filter meter pit. In this pit, the fuel is filtered and metered before it passes through the 302 AF refuel defuel control valve. The control valve reduces the fuel pressure before the fuel is delivered to the hydrant outlet, where the hose is used to connect the system piping to the aircraft. The 302 AF valve also controls system defuels. When the magnet is removed from the KISS switch, the pump of the 302 AF solenoid does both de-energize. The 302 AF was not placed to allow the gravity defueling. During the defuel, the fuel flows from 302 AF to the separate defueling line back of the defueling tank. Note that the most Air Force's bases have been modified to their Panero systems, limit filter meter pits to the MH2 series hose carts. Modification consists of removing the meter and micropneumatic filter from the filter meter pit, installing pipe spools in the place. Alright, 4.4, the system components, a deep well turbine, vertical. Each of the underground operating storage tank has one or 300 to 600 gallon pump. Chapter 3 forms a description in the Chapter 10 of the maintenance frequencies. 4.4.2 non-surge check valve 81 AF and 4.4.2.1 general. A non-surge check valve is in Figure 4.2 is required in the discharge line to each of the deep well turbine to keep the pump surges from damaging downstream equipment and to prevent the reverse flow of the fuel from the filters and separator and the pump. The maintenance frequencies are noted in Chapter 10. This shows Figure 10 is a non-surge valve where the inlet goes from the deep well port turbine and is in the VP valve position indicator in CV flow contract flow control with the swing check valve with two swing check valves and outlets to the filter and separator. 4422 valve settings. Set the valve to open slowly to prevent pressure surges into the filter separator downstream equipment. The typical setting is about 20 seconds with a full range of the 50 to 60 seconds to set the valve in the CV flow control counterclockwise to make the valve open to the faster and clockwise to open slower. The field separator control valve, the FSCV 400AF2A, generally the field separator control valve, figure 4.3 controls the rate of the flow through the separator, prevents the reverse flow, prevents the water dam discharge when the flange float controls the reach of the high position. The automatic water drain feature has been disabled except for the certain receipt filters. When the water in the fuel pump is in problem, the water shuts off. Feature slug valve stays active. Alright, this is a picture of 4.3. A filter separator control valve. See the common drain from the field separator going into both the power troll and the auxiliary high troll. There's an orifice plate that goes into the CDSH2 and ejector open for the power troll. Also, this goes into the control valve, autofill refill manifold. 4432 valve settings. Set the rate of flow for the control the discharge valve. Fill nameplate rating, typically 600 gallons per minute, using a CDHSTB, turning adjusting stem clockwise, increasing the flow rate of the counterclockwise to decrease. 444 meters. See Chapter 2 for description. 445 3-port two-way refuel defuel valve. 302 AF, generally a 302 FA in junction with a refuel defuel line in the filter and meter pit. The valve is uniquely in that 3-port automatically control valve that allows the fuel flow in the two directions through some automatic valve, one direction refueling, another the defilling. When the kit switch is set, the hydrant outlet is activated with the 302 AF solenoid. Energizing the valve is ready to refuel. The valve automatically performs the following functions: reduces the measure pressure, goes into hydrant aggressively, hydrant outlet relieves the excessive hydrant outlet pressure, shuts it off in case of excessive flow. Broken hose provides remote control of the valve. The valve is de-energized and provides a means of defueling aircraft by gravity flow. Alright, 4452 pressure settings. 521. Set the pressure reducing control or the CDR to maintain the normal operating pressure for the furthest outlet. The normal operating pressure, the lowest pressure capable of achieving maximum flow rate, smooth operation. The normal operating pressure for the most Type 1 systems is 100 psi measured at the furthest outlet. 5222. Set under unloading the pressure relief control or the CRL to open the defuel side at 10 psi above the normal operating pressure. Set the loading of the CRL to close the refueling side at 5 psi or not above 5 psi above the normal operating pressure. See the CDHS3 according to the procedure attachment 3. 44525. See the CV flow to the open valve as quickly as possible without tripping the CDHS, typical between 15 to 20 seconds. Recommended setting procedures. See figure 44. Alright, your refuel decontrol valve starts with a 4-port cylinder with the common supply going to the CDH, DHBS with a higher and low cocked. From the CDHS and the common supply line goes the auxiliary high troller ejector standard to the CV flow and the CRH, CRD, and opening to the central of the open port. Diaphragm assembly symbol, uploading CRL outlet side of the hydrant type, orifice and common drain, inside inlet side from the pump, and this loading the CRL. Closed. Four, 531. Set the CV flow control to open the valve as quickly as possible without tripping the CDHS3, typically between 15 to 20 seconds. Adjust the CV flow control using the same procedure described in the 81AF valve. The CRD loading and unloading CRL using the following procedure. Both of the bottom CRL S's Energize the system, adjusting with the CRD of the 10 psi, the normal over the pressure, normal operating pressure. Make back out of the underloading of the CRL until the defueling portion of this valve starts. Then open in the 2 to 3 psi drop acceptable. Tighten the jam nut and unload the CRL. Back out of the CDR and for 2.5 psi normal operating pressure. Back out of the loading CRL until the refilling portion of the valve starts to close at 2 to 3 psi drop and acceptable. Is acceptable. Tighten the jam nut and loading CRL. Back up to the CDR and notice the normal operating procedure. Lock the jam nut of the CRD, checking heading of the slowly closing the downstream valve. The refueling valve should close the reduced outlet pressure. If loading the CRL fails, use close the fast enough. The unloading of the CRL will open to dump the exposed excess pressure of the defuel tank. Set the CDH according to the procedure outlined in the attachment. For additional automatic control valve, the troubleshooting procedure refer to the manufacturer manual's hydrant outlet adapter Panero system. Is using 2 types of hydrant adapters, Buckeye and the Philadelphia. The Philadelphia is shown in Figure 4.5. Bases should have been replaced with the adapters in the new API type adapter. Philadelphia hydrant adapter is this. I'm going to back out of this. Basically, you have a cylinder wall with an O-ring and a poppet and on a spring with a cover gasket over the with an arm which goes down the hydrant adapter to the flange gasket and through the flange gaskets. 447 remote controls electrical fixed control stations. The original joy cable fixed control station on Type 1 hydrant system should have been converted to magnetic control switches similar to the KISS switches used in Type 2 system. Emergency switches are single pole type connected in series with power supply line control equipment. The operating pump hoses the switches and provided with the operating personnel at any pit can stop a fuel operation causing the fire and other mishaps. After activation of emergency switches, the control is operating. The pump house must be manually reset to resume fuel refueling. 448 defueling tank. A deep well turbine is installed with the defueling tank to transfer the product of the bulk storage operating tank. The defueling tank should be equipped with a high level alarm to warn personnel of the fuel level in the tank approaching the predetermined fuel level. The high level control valve to shut off the flow of the fuel tank. Liquid level gauge and low level control. A liquid level gauge and a low level control are installed. Figure 4.6 are installed in to shut down the pump automatically. The liquid level gauge and the low level control prevents the withdrawing of the fuel from the tank below the predetermined level, typically 330 millimeters or 13 inches on the underground tanks, and prevents the pump from running dry. The gauge had a low control level switch, dial, support column, push rod connection, float arm, and float. High level 4410 high level control valve pan type. The 124 AF figure 47 shows the valve. It shuts down full heats of the tank will be predetermined level, typically 279 millimeters or 11 inches from the top of the tank, reaching the maintenance frequency. Note on chapter 10. The high level shut off of the main valve flow to the tank of the flange through the controlling tube and the supply tube into the pilot valve to the float and the float rod and the counterweights. Chapter 5, hydrant fueling system, typically Type 2 Pritchard base.